All right, let's just dive right into it. Today, we're decoding the 7-layer OSI model to build your ultimate CCNA study guide. Seriously, if you're gearing up for that certification and want a rock-solid foundation in network communication, you are exactly in the right place. Let's get to work. So here's our game plan. We're breaking this down into 6 quick chunks. First, an intro to OSI for the CCNA, then the host layers 7, 6, and 5, next the transport layer at layer 4, followed by the media layers 3, 2, and 1. After that, we'll hit encapsulation and PDUs, and we'll wrap it all up with security and troubleshooting.
Okay, Section 1. Intro to OSI for the CCNA.
Now you might be wondering, why bother with a theoretical model from way back in 1984? Well, for the CCNA exam objectives, you literally cannot pass without knowing how to compare the OSI and TCP/IP models. You've got to know exactly how applications, devices, and protocols map to these specific layers. Where do IP addresses live? What about frames or, the actual physical cables? You need to know this stuff cold. Think of the Open Systems Interconnection model, the OSI model, as your master map. It's a 7-layer conceptual framework. Data moves up and down bidirectionally through these abstract layers. It goes all the way from the physical hardware at the very bottom right up to the software application interface at the top. And as we'll see, it's broadly split into 2 camps: the top, host layers, and the bottom, media layers. All right, moving on to Section 2, the host layers, layers 7, 6, and 5. Let's start from the very top and work our way down. These top 3 layers are all about software. They focus heavily on the user experience, handling the really complex protocols that let your programs actually talk to each other across a network. Right at the top, we have layer 7, the application layer. This is the one closest to you, the end user. If you're sending an email, this is where your email app interacts with the network. You definitely need to memorize the key protocols here for the exam: HTTP, SMTP for your email, FTP, and DNS. But because it sits right there interacting with users, it's super vulnerable to things like phishing or SQL injection. Honestly, this is why network engineers jokingly call user error a layer 8 problem. Stepping down one rung, we hit layer 6, the presentation layer. Think of this as the ultimate data translator. It handles data formatting so that what one system sends, another system can actually understand. But it also does some heavy lifting with data compression and encryption, stuff like your SSL and TLS protocols. So, if a bad actor is launching an SSL or TLS stripping attack, yep, it's happening right here at layer 6. Next up is layer 5, the session layer. Picture this layer as the manager of the conversation. Its whole job is to establish, maintain, and eventually terminate communication sessions between apps. And it has this brilliant feature where it implements checkpoints. If a massive file transfer gets interrupted, you don't have to start from scratch, it just picks up from the last checkpoint. It's a total lifesaver. On the security side, though, watch out for threats like session hijacking and DNS poisoning here.
Okay, Section 3, the transport layer, layer 4.
Now we are right in the middle of the stack. Think of layer 4 as the ultimate border crossing. It is literally the bridge connecting the software world we just talked about down to the hardware world we're about to enter.
At layer 4, the name of the game is reliable end-to-end data delivery and traffic management. For the CCNA, there are 2 major protocols you absolutely have to memorize here. First, TCP, or Transmission Control Protocol. You use TCP when you need a guaranteed connection-oriented delivery. Every single packet matters. Then there's UDP, the User Datagram Protocol. That's for when you just need pure speed and don't care about a perfect connection. Security-wise, this layer uses IPsec and TLS, but it's also a prime target for SYN flood attacks.
Moving right along to Section 4, the media layers. That's layers 3, 2, and 1.
Okay, we are officially descending into the physical infrastructure. These bottom 3 layers, network, data link, and physical, are completely hardware-focused. This is the physical gear and the very strict rules needed to navigate it.
Layer 3 is the network layer. When your data needs to leave its local neighborhood and figure out the best physical path across a bunch of complex networks, it happens right here. This layer is all about logical addressing, specifically your IP addresses. Because it routes all this traffic, it's guarded heavily by firewalls, routers, and access control lists, or ACLs, to fend off nasty stuff like IP spoofing and denial of service attacks.
Stepping down again, we hit layer 2, the data link layer.
Now, unlike Layer 3, Layer 2 is strictly local. It's basically managing error-free transfers between devices on the exact same local network segment. To do this, it relies on MAC addresses, not IP addresses, and it packages everything into units we call frames. Securing this layer means configuring your switches to block things like MAC spoofing, MAC flooding, and ARP spoofing.
And we've hit rock bottom. Layer 1, the physical layer. This is the tangible stuff. We are talking actual cables, hubs, fiber optics, electrical signals. Its one and only job is to transmit raw ones and zeros, just raw bits. Security down here isn't about writing better code, it's about physical access control, keeping people out of the server room, preventing tampering, and, well, making sure the router's actually plugged into the wall before you spend 3 hours troubleshooting.
All right, Section 5, Encapsulation and PDUs. So how does the data actually make this journey? Well, the magic word is encapsulation. As your data travels down from Layer 7 all the way to Layer 1, every single layer adds its own specific header, and sometimes even a trailer, to the original data. It's kind of like putting a letter inside an envelope, and then putting that envelope inside a slightly bigger envelope at every step, getting it fully prepped for the physical wire. This next part is massively testable for the CCNA. At every single layer, that newly encapsulated envelope gets a very specific name. We call it a Protocol Data Unit, or PDU. You have got to map these perfectly. At Layer 4, it's a segment if it's TCP, or a datagram if it's UDP. Down at Layer 3, it becomes a packet. At Layer 2, it's structured into a frame. And finally, at Layer 1, it hits the wire as raw bits. Seriously, lock this mapping into your memory right now.
Finally, Section 6, Security and Troubleshooting.
Let's bring this all back to the real world. While the 7-layer OSI model is a phenomenal teaching blueprint for understanding architecture, we have to remember that the TCP/IP model is the actual practical protocol suite running the internet today. TCP/IP condenses things into just 4 or 5 layers to handle massive amounts of traffic. But even so, the OSI model remains an absolute staple for engineers. You might be wondering, if we use TCP/IP, why do we care so much about OSI? Because it gives you a systematic framework for troubleshooting. If the network goes down, a pro doesn't just guess. They start at Layer 1. Is the cable plugged in? If yes, maybe jump to Layer 3. Are there IP routing errors? If that's fine, check Layer 7 for a software bug. Plus, this layered approach means developers can update a protocol at one layer without totally breaking the rest of the network stack. It's an absolute lifesaver. So, knowing what you now know about this foundational blueprint, let me leave you with this. Are you ready to actually test your knowledge on these 7 layers? Honestly, mastering this model backwards and forwards won't just get you through the CCNA, it's going to make you a legendary network troubleshooter in the real world. So, where are you going to start your review?